2, 3.
Hello everybody, this is a course in collisions, but today we're going to talk about pi. Pi stands for perfectly inelastic, inelastic, and elastic, which are the three basic collisions we know in the physical world today. But before we can dig into the pi, we have to talk about a concept called momentum. Momentum is defined as a tendency for an object to move, and this is completely driven by kinetic energy, which is the energy of motion. And momentum cannot be created or destroyed, which is one of the most fundamental concepts in physics.
3.
To begin, we're going to start with elastic collisions. Let's say that two cars of different masses are going different speeds. They collide head-on along a straight road and leave the collision site with different velocities, like this. Because this is a closed system, meaning no external forces but gravity is working on the cars, the momentum of the collision is conserved. So the total energy before the collision equals the total energy after the collision. Next, for an inelastic collision, let's say that one car with a mass is parked in a parking lot, and the second car with a different mass is moving with a speed towards the parked car. The moving car collides with the parked car like this. In this situation, the total momentum of the system is not conserved. So the energy before the collision does not equal the energy after the collision because some kinetic energy is transferred to the parked car from the moving car.
3.
For the final collision, it's perfectly inelastic. So, let's say that two cars of different masses are going different speeds initially. They collide head-on along a straight road and stick together like this. After the collision, because the cars are stuck together, they move with the same speed since they are now one body. The momentum of the system is conserved, so the total energy before the collision equals the total energy after the collision.